Welcome to The Explainer. Today, we're diving into something pretty wild. It's a new idea that could totally flip our understanding of time on its head. Forget time as a river that flows. What if it's more like a solid block that just is? All right, so let's just jump right in with a question that honestly sounds like something from a sci-fi movie, but it's a very real headache for physicists. And get this isn't just some abstract what-if scenario. We're talking about real experience, like one with the amazing name, the delayed choice Cheshire Cat. And what they found is just bizarre. It seems like a decision someone makes right now can actually change what a particle was doing in the past. I mean, how does that even work? It messes with everything we think we know about cause and effect. Okay, so you've got this evidence staring you in the face, evidence that says the future can kind of reach back and mess with the past. What do you do? How on earth do physicists even start to wrap their heads around that? Well, for a long time, the approach has been to try and explain it as a process happening in time. A really, really weird one, but a process nonetheless. Let's look at a couple of these ideas. They're super clever, but you'll see, they get complicated fast. So first up, we have something called the Parisian zigzag. Picture this. A scientist makes a choice over here. That choice sends a signal backward in time to where the particle first came from. And then, from that point back in the past, another signal shoots forward in time to a different particle. It's literally a zigzag across the timeline. Future to past, then past to future. Okay, then there's the quantum handshake. This one's a little different. Imagine a source sends out like an offer wave into the future. Then, from somewhere up ahead in time, a detector sends back a confirmation wave into the past. And right in the middle they meet. It's like they shake hands across time, and that's the moment that makes reality, well, real. Now look, these ideas are fascinating, right? But they are also incredibly complex. It's a lot of mental gymnastics. And that has led some physicists to step back and ask a much bigger, much more radical question. What if we're looking at this all wrong? What if there's no process at all? What if time itself is the part we're not getting? And this is where things get huge. We're not just talking about a new theory. We're talking about completely gutting our most basic, intuitive picture of what reality even is and swapping it out for something else entirely. So here's the core question, the fundamental choice we have to make. Is reality like a movie, playing out one frame at a time where the future is still up for grabs? Or is reality more like a sculpture, a finished piece of art that already exists all at once, where every moment, from the very beginning to the very end, is already there, coexisting? This new theory actually has a name for this sculpture, the whole content. Just think about that. It suggests that reality is a single, static, four-dimensional block. Past, present, future, they're not separate things. They're just different places in this one massive object. So the moment you were born, the moment you're listening to me right now, and every single thing that will ever happen in your life, they're all just coordinates on this 4D map. So here's a way to picture it. The 3D world we see and feel around us, that's just one slice, like a single page in a book, or maybe a shadow of the true 4D reality. And that feeling of time passing, of things moving, of one thing causing another, according to this idea, that's all an illusion. It's just what our consciousness experiences as it moves through the different slices of this static block. It's literally like our awareness is flipping through the pages of a book that's already been completely written. Okay, so how does thinking of reality as a giant sculpture actually help with those weird quantum puzzles we talked about at the beginning? Well, it's simple. If reality is a sculpture, then those strange effects aren't weird processes happening in time. They're just features of its shape, its geometry. And this is where this new way of looking at things is just so elegant. That whole Parisian zigzag, it's not a weird path through time, it's just the 3D shadow that a single solid object in 4D happens to cast. The quantum handshake, not two waves meeting, it's just us looking at the same timeless object from two different angles. Suddenly the paradoxes just evaporate. They were never about weird cause and effect. They were about us getting confused by the shadow because we couldn't see the real object casting it. But of course, an idea this huge, this fundamental, isn't going to be accepted by everyone. In fact, it kicks off a huge debate, a real philosophical battle over what reality is at its most basic level. So the question becomes, what is the real stuff of the universe? In one corner, you have this new theory, TCGS, saying that a physical 4D geometry is the real deal. Spacetime is the territory. But in the other corner, you have a rival idea that says, no, information is what's fundamental. All those quantum connections and relationships, that's what's real. And spacetime, that's just something that emerges from it, almost like a user interface. And this leads to this incredibly profound disagreement. Is geometry the territory, and information just the map we use to describe it? Or is information the territory, and geometry just the map that our minds create? It's a total fork in the road for how we think about everything. And this new sculpture idea also goes head-to-head with the many worlds theory, which is pretty popular. The sculpture view is completely deterministic. There's just one block, one reality, one story. What we think of as probability is really just our own ignorance. We don't know exactly where we are on the sculpture. But many worlds says the exact opposite. It says every quantum possibility is real, and the universe is constantly splitting into countless parallel timelines to accommodate all of them. So what's the bottom line? What should we take away from all this? Well, it's that this isn't just a fun philosophical argument. This sculpture of reality idea actually points towards a whole new way of doing physics. Yeah, think about it. If this idea is on the right track, it completely changes the job description of a physicist. They stop being storytellers, trying to narrate a sequence of events unfolding in time. Instead, they become cosmic cartographers. Their job is to draw the map of this timeless, four-dimensional reality. And what's amazing is, this isn't just a future dream. This is happening now. At the very edge of computational physics, this map-making idea is already in play. You've got algorithms designed specifically to map out weird geometric shapes in quantum systems. And you have researchers working on something they literally call matrix model cartography to try and map the geometry inside a quantum black hole. And here's the kicker. This whole cartography approach isn't some fringe proposal from the sidelines. It's actually the approach that's being used right now at the frontier of quantum gravity research. It's how physicists are tackling massive mysteries, like how black holes seem to be holographic projections. Which, of course, leaves us with one last truly mind-bending question to chew on. If this sculpture view of reality is even close to correct, if our entire lives are just a path traced through a universe that's already finished, what does that say about free will? What does it mean for our choices? It's a thought that challenges our most fundamental sense of who we are and what it means to live a life.